Good morning, dear students, and I am in the process of covering the course on engineering thermodynamics. Today I am in my sixth lecture, and that is Principles of Thermometry. As of now, I have discussed about introduction of thermodynamics, pure substances, properties, zeroth law of thermodynamics, pressure, temperature, equilibrium. These all things I have discussed. In my last class, I have discussed about zeroth law of thermodynamics, which states about the equilibrium, and that found the basic principle of temperature measurement, and that is called the thermometry. So thermometry is done by finding the equilibrium between A, B and C. So this zeroth law states that if a system A is equilibrium with system C and system B is equilibrium with system C, then A and B both will be in equilibrium with each other. So that is the basic principle of the zeroth law of thermodynamics, and that gives the basic principle of thermometry. So I am just discussing today on this topic, that principles of thermometry. In today's class, I am going to discuss in detail about concept of temperature, principles of thermometry, forces that determine use of thermometer, fixed points, thermal expansion, types and calibration of thermometer. So I will try to complete these topics very fast. So I will go with the concept of temperature initially. So temperature is a pointer for the direction of energy transfer as heat. So we have seen in our zeroth law of thermodynamics that temperature, this equilibrium will happen, or the heat transfer will take place from high side to lower side. And this is shown here, that if the TA, the temperature of A here, is greater than the temperature of B, the heat will transfer from A to B. And in this case, the B is higher temperature, so heat will transfer from B to A. This slide I have already explained in my previous class also. I will not take much time on this. So when the temperature of two bodies are the same, thermal equilibrium is reached. The equality of temperature is not only requirement for thermal equilibrium. So here, principles of thermometry, this is the topic, and any property of a material which changes with temperature can be used to indicate or measure the temperature. So here, any property of material like expansion or pressure or volume or anything, any property of material which changes with the temperature can be used to indicate or measure temperature. Okay, so like if you increase the temperature, it will expand. Expansion of liquid, solid, liquid and gases. So this volume of this thing can be changed. The pressure also, the resistance also. These things can be used for measurement of the temperature. So here, example of thermometry, volume of a solid, liquid and the gases. So example of thermometer, a laboratory or a clinical thermometer where the volume of the liquid changes with the temperature. So the thermometer which we use for a medical or doctor, they use the volume of the mercury is increasing. Electrical resistance, an electrical resistance thermometer in which the resistance of a length of wire changes with the temperature. So because the wire temperature is also directly proportional to the temperature of the wire. Then color. A pyrometer in which high temperature are judged by comparing the color of a hot object with a reference color scale. You may see the welding or in your home, the gas. I have observed so many times. I think you might have may observe or may not observe. When your gas cylinder is going to, the gas is less in the gas cylinder, the flame will become yellowish. But if the gas is more inside the cylinder, the blue, very dark blue initially, slowly, last day or last to last day of your emptying the cylinder, your flame will be somewhat yellowish. So you can find out from there also. And for the welding, that arc welding and all, this you can, this gas welding, this you can see the flame and how this mechanic is adjusting the valve, and as per the, if you want more temperature, your flame will be very, very blue. So accordingly, your color is also very important to understand that what is the temperature. Voltage also very important for the thermocouples thermometer, in which junction between two wires of different metals generate a voltage, that is called EMF, when the junction are at a different temperature. So if the junctions are in a different temperature, there will be some voltage, and that voltage will be directly proportional to the temperature of the system. Factors that determine thermometer use. So how we can determine that? What are the factors are very important for the thermometer application? How small, portable and convenient is the thermometer? Size. The first is the size of the thermometer. Can the thermometer give continuous reading and be connected to an electrically operated chart recorder or warning device? Can the thermometer give continuous reading and be connected to an electrically operated chart recorder or warning device? How expensive is it? The cost of this thing is very important. Does the thermometer work over the range of temperature required? So how much range your thermometer can use? Is the thermometer sensitive enough? Can it detect small enough changes of temperature? How quickly does the thermometer respond? How fast? As and when you touch your body, very fast it should give the reading. Otherwise, you are waiting for half an hour, means it is not good. So as quick as it is. So these are the factors which are very much important. How small, portable and convenient is the thermometer? I think. Okay, so it is repeated here. So used to calibrate the, so what is the fixed point? Used to calibrate the scale of the thermometer. So these fixed points are used to calibrate, like water. The lower fixed point is the temperature of melting pure ice, also known as the ice point. The ice point is fixed at the 0 degree centigrade. So it is for a centigrade scale 0 to 100. We fix that melting point of the ice is 0 degree centigrade. And upper fixed point, actually it is 99.6, but we say it is 100 degree centigrade. So the upper fixed point is the temperature of the steam just above boiling water and is known as the steam point. The steam point is 100 degree centigrade. So 0 degree centigrade and the 100 degree centigrade, these two fixed points for any thermometer we should know accordingly from 0 to 100. And because this water is having the equal amount of, so we calibrate in a linear way, 1, 2, 3, 4 up to 100, we can calibrate the scale. So this, for any thermometer, this scale we have to know, and this fixed point we should know, then only we can do the things. Temperature relates to, so temperature of a body indicates the amount of kinetic energy of the molecules. Molecules with high kinetic energy means the body is hot. So we can just actually this temperature is what? if this is the body, there are number of molecules. These molecules are rotating, moving randomly here, there, like this. And how much fast they are moving, how much they have the kinetic energy, that is called the kinetic energy, that much temperature of the body will have. So temperature of a body indicates the amount of kinetic energy of the molecules. Each molecules will have some kinetic energy, and as per this energy, their motion, the velocity will be high. We know the kinetic energy is half mv square. So if the k is more, mass is constant, it means velocity will be high. So as you have more velocity, that much collision in the body will be there, that much friction, and that much heat will be generated, and that will give the high temperature if the kinetic energy is high. Molecules with high kinetic energy means the body is hot and the temperature is high. So that is the meaning here. Here I have given some link here. This link can be used to find out how these things are happening. Thermal expansion, how it happened. Heat, and first you take one inside, heat an object, it gains. So if you heat it here, this is the some flame. If you heat there, the kinetic energy will increase. Molecules vibrate more rapidly. So each molecules will start vibrating. If it is solid, they will vibrate in their own position. The molecules push their neighboring further away, and they will start pushing each other. The result is in slight change in distance between the adjacent molecules, and this is called expansion. So if you see here, there are so many. I am just putting some molecules, 1, 2, 3. So if you heat it, they will push. This will go somewhat here. This will push here. This will move. This will move. So there will be a gap, and this thing will increase. This is called the expansion of the system, or expansion of the material. So here next is the thermal expansion of a bimetallic material. We use for our thermometry bimetallic strips. For our temperature measurement, two different conductive materials we are using, and they will give a different voltage, and that voltage difference will be directly proportional to the temperature. So here, this we can see that here we have one brass and iron. The top side is here brass, this is the brass, and this is the iron here. And if you heat it, initially they are straight, but as you heat it, it will bend like this, because the expansion of the brass will be higher than the expansion of the iron. So this will try to push down like this, and this it will be in this shape. So bimetallic strips made of two types of materials. One material expands more than the other. The materials that expands more forms the outer part of the curve. So if you see here, the brass is expanding more, so it is a outer part used in the thermostats. So this is used for measurement of the temperature, and that is called the thermostats. This bimetallic materials are sufficiently used to measure the temperature of the. So it is one of the principle for measuring the thermometer. So the temperature, and that is called the thermometry. Now I will go something about temperature, because we have to discuss about thermometry. So we should know about the temperature also. So what is the temperature? Temperature refers to the measure of the hotness or the coolness of an object. In other words, it indicates the amount of thermal energy an object contains. So it gives the how much it is cooled or hot. If it is cool, we will say the temperature is less. If it is hot, we will say that temperature is more. and this indicates the how much thermal energy it contains. The SI unit to measure the temperature is Kelvin. Degree Celsius is another commonly used metric scale. What is the temperature scale? A temperature scale is a calibrated system for measuring temperature, making it necessary for studying changes in temperature and heat transfer. A thermometer is an instrument that uses a temperature scale to measure temperature accurately. So this thermometer is what? It is an instrument that uses a temperature scale to measure the temperature accurately. Any physical property that changes with temperature is called the thermometric property. So if any physical property which if you apply the temperature or heat, if it is expanding, contracting or anything, it changes its configuration, then we can say that this is a thermodynamic or thermometric property. Thermodynamic properties and temperature scale. This topic I am going to discuss, and in this you can see that there are some thermodynamic property and what types of thermometers are used. So in this you can see that the volume of a fixed mass of a liquid. So this is the volume. Liquid in glass thermometer which either uses mercury or alcohol. So for this volume we use the mercury. Most of the things, if you see the medical for fever measurement, we use the mercury, and also we use the alcohol in some of the thermometer, because mercury is very heavy, so less height is required. But if you use the alcohol, more length of this thing will increase. So for experimental in labs and all, we can use the alcohol. It gives more accurate, but length we need more. Electromotive force, that is EMF. Thermocouples thermometer for measuring the engine temperature or high temperature devices. We cannot use this mercury and alcohol. That time we need some thermocouples where two different types of material. Just now before I have explained about the bimetallic material, like this we use, and where we construct the thermocouples, and these thermocouples are mostly used for high temperature like gas turbine engine, your IC engines, your 2-stroke, 4-stroke temperature measurement of car and all these things we use. The resistance of a piece of a metal, the wire resistance will change as per the temperature. Resistance of thermometers, also known as the resistance thermal temperature detector, RTD. These things are also used, and these properties are used to measure the temperature. So how to define a temperature scale? In order to define a temperature scale, you will need the following. Number one, a thermometric property that varies linearly with the temperature. Any property like volume or pressure, anything that is linear with the temperature. This means that the property changes by a fixed amount based on every unit change in temperature. So if you increase 1 degree, how much extension or the property amount is changing, that should be there. Two temperature points, also known as a fixed point, I have discussed just before, which are standard degree of hotness or the coolness that are easy to obtain, is reproducible. So means minimum and the maximum of any substance, it is also to be noticed. Now I will discuss about types of thermometer. So in this we can see that we have different types of thermometers. Today there are variety of thermometers available. In this article we will be covering the first two thermometer as listed in the table above. So in the first two we have seen that this we will be seeing liquid in glass thermometer, like your medical thermometer which we are using, liquid in glass thermometer. It works based on the principle of thermal expansion of the substances. So if you see the mercury is inside, and if you put this thing in the hot zone, the mercury will expand. So it works on the principle of thermal expansion of the substances. The volume of this mercury or the alcohol which will change, which I have discussed in the previous table also. When the thermometer is subjected to heat, the liquid in the capillary, the slender glass tube, expands. Once the liquid is cooled, it is again contracted. Based on the resulting height of the liquid level, you will be able to read off the temperature. Next is the liquid used has to meet a set of conditions. Which type of liquid? We cannot put water, because water will stick and it will not be in the proper way. So the liquid must not freeze at low temperature. The liquid should have a significantly high boiling point so that they won't vaporize at a high temperature. Means at low temperature it should not freeze, and at high temperature it should not start evaporating. The liquid must be able to expand evenly with the temperature within the measuring range. Liquid that meets these properties are deemed suitable for use in liquid in glass thermometer and are referred to as a thermometric liquid. So for this type of our medical thermometer, we should use the liquid, and this liquid normally we use the mercury. So now next is the calibration of thermometer. How we have to calibrate? Like the water, the freezing, we are assuming as a 0, and at the boiling we are assuming as 100. So 0 to 100, thermometer will increase in that ratio, and we will divide each 1 by 1, 1 by 1, and in this way we can calibrate the thermometer. Calibrating a liquid in glass thermometer and simple thermometer, how to calibrate? The two fixed points used in a liquid in glass thermometers are steam point, that is upper fixed point, the temperature at which pure water boils at 1 atmosphere pressure of 100 degrees centigrade. So that is the steam point. Then ice point is the lower fixed point, the temperature when pure ice melt at 1 atmosphere, that is pressure at 0 degrees centigrade. Last two steps in calibration a liquid in glass thermometers are as follows. Record down measurement of the respective physical property. So how much mercury or alcohol is extending, for we will 1 degree we will increase, and how much it is increasing. We will just calibrate and we will mark on this. Note down the values of the physical properties of the substance at the two fixed points. Set up the scale. Between the two fixed points, divide them equally into 100 parts. Each marks on the thermometer is a measure of 1 degree centigrade. So like this, we can calibrate our thermometer. So now, next, very important is a thermocouple thermometer. In engineering, normally we use this type of thermometer to measure a high temperature devices, especially gas turbine engine, IC engine, or boiler, or so many applications are there for the measurement of the temperature. So a thermocouple is formed by two types of wire which are made of different metals such as copper and the iron. The two ends of both the wires meet to form two junctions. So if you can see here, this is the one wire, this is the Cu wire, and this is the one wire of Fe, copper and the iron, and these two wires are joined together at both the ends. The condition for the thermocouple thermometer to work. So what are the conditions? How it is working? Both junctions will each produce a small EMF. So if you put at hot zone and this is in the normal zone, both junction will each produce an EMF. So there will be EMF. Both junction will each produce a small EMF with a difference in temperature between them. So how much temperature? The difference between, suppose it is a 20 degree centigrade atmospheric and this is the 500 degree centigrade. Accordingly, here this meter will give here 0 to 500 degree centigrade, and this you can calibrate as per the requirement. The temperature can then be calculated using a millivoltmeter. So just I have shown you, this is the millivoltmeter, a small amount of millimeter it will indicate, and this will be directly proportional to the temperature of the system. One junction usually remains at a fixed temperature while the other is used to measure the unknown temperature. So this is the fixed temperature at atmosphere, and another is unknown. And this is unknown where we want to measure the temperature. The equation is here epsilon directly proportional to V, where this E is a EMF generated and this V is difference in temperature between both the junction, and these are here. So in this way we have seen that how we can measure the temperature. Here this is the engineering application, this one is engineering application, that is engineering application of the system. And normally we use this type of system. We can also make it in our lab, we can do our own, how we can calibrate and all. So this I have discussed about thermometric, and in my next class I will solve some problems related to pure substances. 2-3 classes, next 2 or 3 classes I will take some numericals and we will be solving some pure substances, use of steam table, heat and energy. This all I am going to solve, please. So these are my references: Principles of Thermodynamics PDF, P.K. Nog, Engineering Thermodynamics, Tata McGraw-Hill's, Yunus Sengel, Michael, and this is the Thermodynamics and Engineering Approach and Principles of Thermodynamics. I have taken from there. If any questions, you are welcome to ask. It will be my pleasure to react. This is my email. This is my email. Please do see and like and give any comment in this video. Thank you very much. Be tuned for my next lecture, and it will coming soon. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.